Slopes of isothermal and adiabatic curve. Now to find out the relation between the slopes of adiabatic and isothermal curves, we have to use the equations for these processes. First of all, since we know that the indicator diagram is, for indicator diagram, pressure is along the y-axis and volume is along the x-axis, and the graph is like this. Okay, so basically slope is given by tangent theta is equal to dp by dv, right? So basically we need to find out dp by dv. Now for isothermal process, equation is pv is equal to k, constant tha. So now we will differentiate. For differentiating, we will use the equation method of product method. P dv plus v dp is equal to differentiation of constant is 0. So v dp is taken one side and p dv is taken to another side, right? So dp by dv we need to find out. So dp by dv is equal to minus p by v. We will give it number 1. Now for adiabatic process, the equation was pv raised to power gamma is equal to constant, which is k. Now when we differentiate it, p, now differentiation of v to power gamma is gamma v to power gamma minus 1 dv plus v to power gamma. Now for pressure it is dp is equal to 0. Constant differentiation is 0. Again we will keep dp to the left hand side. So v to power gamma dp is equal to p gamma p with negative sign v to power gamma minus 1 dv to right hand side. Now dp upon dv we need to find out dp by dv, which is equal to minus gamma p v to power gamma minus 1, and this gamma is taken down, so v to power gamma, right? Now v to power gamma to gamma is cancelled out. We will be left with minus gamma p v to power minus 1. So that is equal to minus gamma p upon v. Now if we compare the slopes for the isothermal curve and the adiabatic curve, we came to know that the slope of adiabatic curve is gamma times the slope of isothermal curve. So we can write here the slope of adiabatic curve, is greater than gamma times, is equal to, we can write gamma times the slope of isothermal curve. So basically if you are given two curves, so and you have to identify which one is isothermal and which one is adiabatic, you will just find out the slope of both the curves. The curve having greater slope will be adiabatic, and the curve having the lesser slope will be the your isothermal. Now let us consider if I draw these two curves. Suppose these two curves are given to you and you have to find out which one is adiabatic and which one is isothermal. What will you do? We will find out the slope. Now if you put a line here, you can see that at this particular angle, this angle is much greater than this one, right? This one is smaller angle and this one is greater angle. So dp upon dv, if we find out for the two particular angle values, you can see that this angle is smaller and comparatively this one is greater. So this is adiabatic curve and this is isothermal curve for the expansion. And if we draw the curve for compression, the curve will be like that. So basically in that case, compression means pressure and volume. Compression means volume will decrease with the increase of pressure, so arrow will going up. And if you check the slope for these two, you can see that the slope for uppermost curve is greater than the lowermost. So it means the uppermost is adiabatic curve and the lower one is the isothermal curve. So this is how we can find out which curve is adiabatic and which is the isothermal curve.